Welcome to Kanerika's podcast, The Digital Shift.
Glad to be here.
So if you just stop and consider the sheer scale of global enterprise operations today, it is honestly kind of wild. Like JP Morgan Chase is currently running over 1,000 artificial intelligence use cases in active production right now.
Right. Over 1,000. It's massive.
Yeah, and then you look at Amazon, and they rely on AI to manage, their entire global inventory, route millions of deliveries, and handle these really complex customer service interactions.
Oh, absolutely.
And they are doing this at a volume that is just simply incomprehensible for a human workforce to execute alone.
It really is a staggering level of operational scale.
Yeah.
And what's crucial for you to understand, especially if you're out there guiding enterprise strategy, is how they actually pull this off.
Right.
I mean, global leaders, they don't achieve this reality through these, isolated pilot projects or small-scale sandbox experiments.
Right. They aren't just messing around in a test environment.
Exactly. They rely on industrial-scale infrastructure.
Yeah.
They run on governed, highly repeatable systems that are specifically engineered for continuous output.
Which brings us directly to our mission for today. We are exploring the architecture of the AI factory.
Yes.
This is that governed, repeatable operating model that shifts AI from a stalled science experiment into a predictable, revenue-generating production engine.
That's the goal.
But to understand how industry leaders scale these capabilities, we actually have to fundamentally redefine what enterprise infrastructure is meant to do in the first place.
Yeah, the paradigm shift here is just massive. I mean, think about a traditional enterprise data center for a second. Historically, you view your data center as a necessary cost center, right?
Right, it's just a line item on the budget to keep things running.
Exactly. Its main job is to keep the lights on. So, managing standard IT workloads, storing files, keeping the email servers up, and just keeping standard enterprise applications afloat.
Right, it's very static.
But an AI factory is engineered with a completely different objective. It isn't just storing data. It is actively processing it to generate new intelligence and consequently generate new revenue.
To really frame this shift, I like to think about how automobiles transitioned back in the early 20th century.
Oh, the Henry Ford comparison.
Exactly, because traditional project-based artificial intelligence deployment, which is the way a lot of organizations still do it, by the way, is very much like custom building a single car in a dusty garage.
It takes forever.
Right. It requires immense manual effort. You are constantly searching for these bespoke parts. It is incredibly slow. And at the end of the day, every vehicle you produce is entirely unique and really difficult to repair.
Spot on.
But an AI factory, on the other hand, is Henry Ford's assembly line. It prioritizes repeatability, systematization, and just seamless end-to-end integration.
And, the market data strongly reinforces that the transition to this assembly line model is already underway. Analysis from Deloitte indicates that 73% of enterprise leaders expect to have AI factories operating at scale by the year 2028.
Wow, 73%? That's practically everyone.
Yeah, it's a massive shift.
Well,
Furthermore, McKinsey projects that global data center spending will reach a staggering $7 trillion by 2030.
$7 trillion.
$7 trillion. And that massive financial outlay isn't for your standard server racks. It's driven specifically by this complex AI factory build-out.
Okay, so if an AI factory is the modern digital assembly line, we really need to understand the conveyor belts and the heavy machinery that actually make it run.
We do?
So let's deconstruct this architecture into 4 interdependent layers. But rather than just, listing them out like a textbook, let's look at how they fuel one another.
I like that approach.
It has to start with the physical reality, right? The physical bedrock of the factory.
Absolutely. The foundational layer is infrastructure and compute. And this isn't your standard enterprise hardware. We're talking about high-density graphical processing unit, or GPU, clusters.
Right, because standard processors just can't handle the load.
Exactly. GPUs are fundamentally different because they handle parallel processing. They can calculate thousands of operations simultaneously, which is exactly what training a massive neural network requires.
But with that level of parallel processing comes some really intense physical demands. I mean, you can't just drop high-density GPU clusters into a legacy server room, right?
Oh, you would melt the servers or overwhelm the local power grid within minutes?
Just immediately fry the system.
Literally.
Yeah.
Sustained GPU throughput requires accelerated storage, high-speed networking, and highly specialized infrastructure. You specifically need advanced liquid cooling systems and just immense power distribution capabilities.
And all of that massive computational power, all of that heat and energy is ultimately just an engine. And, well, an engine needs fuel, which drives us right into the second layer.
Data in integration.
Exactly. This is the raw material flowing into the factory.
Yeah, and the compute layer is functionally useless without clean, governed, and highly accessible data spanning across your edge and cloud environments.
Right.
The models are only as intelligent as the raw material they ingest. If you have pristine infrastructure, but your data is fragmented and siloed, your factory produces absolutely nothing of value.
Which perfectly sets the stage for the third layer, the AI platform and model layer. This is the central hub where the actual intelligence generation happens, right?
Yes, this is where large language models are trained and fine-tuned. It's also where we see technologies like retrieval augmented generation pipelines, or ARGI, deployed into active service.
And for anyone unfamiliar with the mechanics of a ARG pipeline, it's worth a quick explanation because it's just so vital to enterprise AI.
Oh, definitely. So instead of relying on a model's static pre-trained memory, where it might hallucinate or just guess an answer,
Yeah.
a RAG pipeline essentially gives the AI an open book test.
I love that analogy, an open book test.
Right. It forces the model to retrieve specific governed information from your proprietary enterprise data before it generates a response. It grounds the AI in your factual reality.
Which is an incredibly powerful capability provided the underlying rules are rock solid. Which naturally brings us to the fourth layer, the operating model and governance.
The rules of the road.
Exactly. This encompasses the intake processes for new use cases, the strict risk frameworks, and the comprehensive audit trails required for compliance and security.
It's what keeps the factory from burning down.
Right. But, looking at this holistic architecture, compute, data, platform, governance, I want to push back on a prevalent industry narrative we see all the time.
Okay, let's hear it.
Well, everyone is obsessed with Layer 3, the shiny new language models, but isn't the actual bottleneck for most enterprises sitting in Layer 2 the data?
Oh, without a doubt.
Right, because if the raw material is flawed, doesn't the factory just produce flawed intelligence faster?
You've hit on the exact reason why so many highly funded enterprise initiatives just stall out completely. The AI factory does exactly what it is engineered to do. It amplifies whatever raw material you give it.
So it just scales the mistakes.
Exactly. If you feed fragmented, outdated, or inaccurate data into a highly advanced model, the model will confidently output incorrect decisions at an unprecedented scale.
So because enterprises obsess over the models rather than fixing the data or establishing the governance, their factories often just grind to a halt before they ever reach production.
Happens all the time.
Our team sees these failure modes consistently, and they usually stem from a few predictable operational gaps.
Yeah, and data fragmentation is always the primary culprit.
Hmm.
Organizations have decades of historical data trapped in legacy formats.
Locked away in silos.
Right, locked in disparate mainframes, completely disconnected from modern data pipelines. You just cannot run a real-time AI agent on data that has to be manually exported from a 20-year-old database.
It's impossible. And the second major failure mode we observe is attempting to retrofit governance. Oh, that's a nightmare.
It really is. This is when an enterprise tries to bolt on security rules, bias monitoring, and access controls only after the pipelines are already live and operational.
Which you just can't do effectively.
Right. Mechanically, trying to retrofit governance is like trying to install brakes on a sports car while you're already driving it down the highway.
That is a terrifying image.
It's dangerous, it's expensive, and it usually ends badly.
And let's look at why that analogy holds up technically. When you retrofit governance, you aren't just flipping a switch. You are forced to untangle interwoven code and security protocols from live models.
Which means taking things offline.
Exactly. You end up breaking your own data pipelines, tearing down functioning systems, and causing massive operational downtime. It is an expensive nightmare that severely delays any realization of business value.
Beyond the technical debt, there is a very human failure mode here too, which is a severe talent gap. The reporting from Randstad indicates that only 13% of workers have received formal artificial intelligence training.
13% is incredibly low. It is. You simply cannot operate a highly complex manufacturing system without a workforce trained to understand its outputs.
You really can't. And these failure modes, the fragmentation, the governance issues, the talent gaps, they are also heavily influenced by your fundamental deployment choices.
Right, where you build matters.
Exactly. Where you choose to build this factory dictates your risk profile entirely.
Let's walk through those options. The first option you have is an on-premises deployment. You are purchasing the hardware directly and setting it up in your own facilities.
Right, and the upfront capital cost there is astronomical.
Mm.
But for organizations requiring strict data sovereignty, like those in heavily regulated finance or healthcare sectors, it's often mandatory.
Because the data literally never leaves their physical control.
Exactly. Conversely, you have cloud deployment. The cloud offers ultimate flexibility, immense speed to deployment, and zero hardware procurement delays.
You can just spin up massive compute power in an afternoon.
You can. However, you are trading that speed for variable, sometimes highly unpredictable ongoing costs. And there are potential privacy risks if highly sensitive proprietary data is processed on external multi-tenant servers.
Which perfectly explains why the hybrid model has become the de facto enterprise standard. A hybrid architecture allows you to balance those competing needs.
It's the best of both worlds.
Right. You keep your most sensitive workloads and proprietary algorithms secure on-premises while utilizing the cloud's agility for less sensitive operations and burst computing needs.
Right, like when you suddenly need massive parallel processing power for a short duration.
Exactly. So knowing the architecture and knowing the failure modes, the real question becomes execution. To avoid these massive stalling points, the sequence of how you build this foundation has to be flawless.
It has to be methodical.
And as Kanerika employees, we see this firsthand. At Kanerika, our methodology breaks this construction down into 4 non-negotiable phases: assess and prioritize, build the data foundation, stand up the AI platform, and operationalize.
The sequencing is everything. During the initial assess and prioritize phase, you have to brutally map your desired business use cases against the actual maturity of your data and infrastructure.
Right, no wishful thinking allowed.
Exactly. You establish what is mathematically and operationally feasible today, not what looks good on a slide deck.
And when we move into the second phase, building the data foundation, we at Kanerika always design the data layer first, long before we touch an AI model. We frequently utilize Microsoft Fabric to solve that fragmentation issue we discussed earlier.
Yeah, Fabric is incredible for that. It allows us to unify disparate, siloed environments into a single, governed lakehouse architecture.
And for clarity, a lakehouse is exactly what it sounds like. It combines the massive, flexible storage capacity of a data lake, where you can dump raw, unstructured data with the structured, highly searchable governance of a traditional data warehouse.
Right. It gives the AI models a single, reliable source of truth to pull from. But establishing that unified foundation is traditionally a multi-year endeavor for large organizations burdened with heavy technical debt.
It takes forever. But that multi-year timeline is exactly why we rely heavily on our AI-powered migration accelerator, Flip.
Yes, Flip changes the game completely.
It really does. By deploying Flip, we at Kanerika successfully reduce the migration effort by 50 to 60%.
That's massive.
And it does this mechanically by automating the most tedious parts of database migration. It uses AI to automatically translate legacy schemas, map data structures, and validate the code.
Right, the heavy lifting.
Exactly. We are consistently compressing what used to be a 3-year migration timeline into a 90-day delivery.
And that level of compression completely alters the strategic roadmap. I mean, instead of waiting years to simply organize and migrate the data, the organization transitions rapidly into the third phase, standing up the AI platform.
And then the fourth phase, actually operationalizing the models to do real work.
Yes.
And I want to highlight how that acceleration changes the dynamic in the boardroom. When we use tools like Flip to compress those foundational timelines so drastically, how does that shift the executive conversation?
It shifts it from a cost discussion to a value discussion.
Right, because in my experience, getting the data ready in 90 days allows us to deploy the actual AI agents before the business loses patience and pulls the funding.
It absolutely preserves executive sponsorship, which is arguably as critical as the technology itself. Enterprise leaders demand rapid time to value.
They want to see results.
Exactly. When a data modernization project stretches into year 2 or 3 without producing a single piece of tangible intelligence, the business loses faith. By leveraging Flip to finalize the data foundation in 90 days, we maintain the initial momentum.
So let's talk about that value creation. Once the data foundation is aggressively modernized and secure, the factory can start producing its most valuable assets. Autonomous AI agents?
The digital workforce.
Right. But a critical operational question immediately arises here. Who watches the agents? We need to clearly define the crucial difference between the AI factory and the AI center of excellence.
The distinction is vital for risk management. The AI factory is the technical system itself. It is the compute, the data pipelines, and the platform executing the heavy workloads.
Okay.
The AI Center of Excellence, or COE, is the cross-functional human team setting the rules. The COE establishes the ethical guidelines, the security parameters, and the strict governance. The COE dictates the standards. The factory simply executes them.
Okay, so with the COE defining the governance, the factory can safely deploy specialized capabilities. And this is where the theory becomes reality. We at Kanerika produce a sophisticated suite of autonomous AI agents designed to optimize very specific core enterprise roles.
Yes, and let's detail how these specific agents function within the enterprise architecture, because they aren't just generic chatbots.
No, not at all.
They're targeted digital workers.
Take legal and compliance, for example, which is always a massive operational bottleneck. We deploy Alan, an agent engineered specifically for legal team.
Yellen is brilliant.
Right. Mechanically, Alan uses advanced natural language processing to intelligently ingest and condense lengthy, complex legal and regulatory documents. It extracts the pertinent clauses and risk factors, turning weeks of manual human review into immediate, structured insights.
And on the quantitative side, we deploy Carl, the data insights agent. Carl directly analyzes vast data sets across the enterprise architecture.
So no more waiting on manual reports.
Exactly. Instead of a human analyst spending days writing SQL queries to find a specific trend, Carl understands natural language requests. He writes the necessary queries autonomously and delivers business intelligence 5 times faster than traditional methods.
That is wild.
It gets better. Our clients document a 65% time savings for their analytical teams.
And that kind of time savings shifts the human workforce from tedious data gathering entirely over to strategic decision-making.
Yes, they can actually use their brains.
Exactly. But with speed comes risk, especially regarding privacy. That's why we also deploy Susan, an agent dedicated exclusively to automating personally identifiable information, or PII, redaction at scale.
For organizations handling sensitive customer records, Susan is absolutely crucial. As raw data flows through the pipelines, Susan dynamically identifies and redacts Social Security numbers, medical histories, and financial data before it ever reaches a downstream analytics model.
Which is huge for security.
It maintains strict regulatory compliance without slowing down the data processing velocity.
And finally, we have Clara, our agent engineered for complex document intelligence and instantaneous knowledge retrieval across massive, unstructured enterprise libraries.
Oh.
Clara essentially gives your entire workforce a centralized, instantly accessible brain.
It's like having the perfect research assistant.
Right. But looking at this suite of capabilities, I want to raise a critical pushback.
Okay, what is it?
Well, if we are deploying highly autonomous agents like Carl and Susan agents that are taking direct actions on enterprise data every single second, doesn't that inherently increase enterprise risk if the Center of Excellence isn't strictly monitoring the outputs?
Oh, the risk is substantial if autonomy outpaces governance. That is the exact reason the Center of Excellence must be fully established before a single agent goes live.
Because things can drift, right?
Exactly. Consider the mechanics of model drift, where an AI's accuracy degrades over time as the real-world data it encounters changes. If an agent like Susan experiences drift and fails to correctly redact a batch of PII, the enterprise faces immediate, massive regulatory exposure.
So the COE is the safety net.
Exactly. The COE is responsible for establishing continuous drift monitoring, human-in-the-loop escalation protocols for uncertain edge cases, and immutable audit trails, so you know exactly why an agent made a specific decision.
The agents operate swiftly, but they operate entirely within the strict boundaries enforced by the COE. To truly understand how this entire ecosystem, the infrastructure, the unified data, the governance, and these specialized agents harmonizes, let's look at exactly what happens in a real-world scenario.
Yes, let's ground this.
Our team recently partnered with a large healthcare membership organization that perfectly illustrates this transformation.
Oh, this is a great example. This organization was experiencing a systemic, crushing operational failure. They were completely drowning in high-ticket volumes from their members.
The situation was entirely unsustainable. I mean, the sheer volume of incoming requests was forcing highly skilled senior executives to spend their days handling routine, repetitive member queries.
Things like basic policy explanations and password resets.
Right. And consequently, resolution times plummeted and overall member satisfaction scores were dropping significantly. The human workforce was fundamentally misallocated.
It's a classic symptom of an enterprise lacking an operationalized AI factory. They had massive amounts of data, they had thousands of daily queries, but they had no automated intelligent system engineered to process that wrong input.
The machinery was just missing.
Exactly.
So we at Kanerika intervened. We didn't just give them a faster database, we deployed an advanced AI member support agent, integrated directly into their existing knowledge bases and their Zendesk ticketing environment.
And the underlying architecture of this deployment is what makes it successful. The agent utilized natural language understanding to instantly parse the intent of the incoming tickets.
So it knew exactly what the member wanted.
Right. For routine queries, it resolved the issue autonomously, drawing answers exclusively from the governed knowledge base to prevent hallucinations.
No guessing allowed.
Exactly. But for complex, high-risk cases, say a nuanced claim dispute, the system intelligently routed the ticket directly to the specialized human executives, complete with a summarized brief of the issue.
Furthermore, it auto-generated comprehensive ticket summaries and maintained full audit trails for every single interaction.
Which is
Right, because it satisfied the rigorous compliance and operational requirements of the healthcare sector. And the statistical impact of deploying this factory architecture was massive.
the numbers are incredible.
They really are. The organization achieved a 25% improvement in member satisfaction scores almost immediately. 65% of all incoming queries were resolved entirely through self-service by the intelligent agent.
Over half, just handled instantly.
Yep. And this resulted in a 42% drop in overall incoming ticket volume for the human staff and a staggering 31% decrease in the cost per ticket.
Those statistics represent a total transformation of their service delivery model. And what is vital to understand is that these numbers aren't just standard IT metrics.
No, they're business metrics.
Exactly. They represent a fundamental optimization of core business outcomes. By freeing up the skilled executives from the routine grind, the organization allowed its human workforce to focus entirely on high-value, complex patient care initiatives.
It proves that when the data foundation is solid and the governance is proactive, the artificial intelligence deployed by the factory delivers highly predictable, compounding returns.
It transitions the technology from being a volatile, unpredictable experiment to a reliable industrial utility.
To summarize what we have explored today, the AI factory paradigm is not merely an infrastructure upgrade. It's not just about authorizing a budget for faster servers or licensing a new software tool or running a few isolated pilot programs.
Well, no, it's much bigger than that.
It is a profound structural shift in how enterprises manufacture their most valuable resource, actionable intelligence. It replaces the bespoke manual processes of the past with the governed, integrated, digital assembly lines of the future.
And the competitive reality is clear. The organizations that successfully adopt this structural shift will achieve a velocity and scale of decision-making that traditional manual enterprises simply will not be able to match.
I want to leave you with a final forward-looking thought. We started today by comparing this transition to Henry Ford's assembly line, a system designed by humans to efficiently build a product.
Right.
But if an AI factory is fundamentally designed to continuously turn raw data into intelligence, what happens when the intelligence generated by the factory begins optimizing the factory itself?
Oh, that's a wild thought.
When the agents we deploy start identifying inefficiencies in their own compute utilization or begin writing code to automatically improve their own data ingestion pipelines, are we looking at the dawn of the completely self-improving enterprise?
It's certainly where we are headed.
It is a paradigm where the digital assembly line constantly redesigns itself to run faster and smarter without requiring human intervention. Thank you for joining us, the Kanerika team, for this exploration into the architecture of tomorrow. Goodbye from the digital shift.